Well, hello. Oh, welcome back. I feel like it's been so long, but really, that's the crazy thing about the internet. Because for all I know, you literally just watched a video 12 seconds ago, which would be weird. Oh, yeah, no, that would work. And so here we are in a video that to you, like, it hasn't been so long, but actually, to me, it kind of feels like it's been a while. So I'm glad you're back. We are diving into this concept around converting our units of measurement, right? This is the um next step in a series of great math as we prepare ourselves to move on to the next level of not just thinking about multiplication, division, subtraction, addition, and all that stuff, but how we put it kind of all together based on what's being asked. So today we are doing this. You know me, I like to unpack what we're talking about. We're talking about converting, right? So this concept to convert really just means to change, right? For example, I could convert um 3/10, I could convert that as a fraction into a decimal. That says 3/10, right? So I'm converting. And that is the concept again of equivalent. So things are equal, but they look different. And we're going to talk about that in terms of units of measurement. So how we measure and how we're measuring today is around capacity. This is a weird color. I don't know how I feel about this color. New colors on the screen. Maybe that's why it feels like it's been a while because there's an update with colors. Anyway, we're dealing with our capacity, which is like how much something holds. And we're kind of talking about that concept of volume. And we're doing so in the metric system. Wow, what does all that mean? Let me just circle things and put bubbles around things and draw arrows, and now you obviously understand everything. That's not the case. But we are talking about in this terms today, we're going to talk about how much things can hold in terms of volume, um, in the concept of how we might measure liquids. And we're going to do so in the metric system. And that's what I'll explain next. So let's do that. Let's do that. Let's see. I think this would be our next page. Sweet, did it. Okay. So what we're talking about today is the concept of liters, which we abbreviate with a big L, and the equivalence of milliliters, which we abbreviate with ML. Actually, I feel like that's rough. It is ML. It's just often that ML is written lowercase, actually, because milliliters is a smaller unit of measurement, I guess. It's not really small. That's the always thing that's really funny is that, again, they're equal. It's just how many go into each one. So when we are talking about those things, again, this is that matrix system. We're talking about like how we measure in terms of like a drink. And you'll actually see that. It might tell you like, oh, this has 1,000 milliliters of fluid, or this is a 2 liter of soda. Oh boy, that is not how a soda looks like, but and that's what we really see. It's like how much liquid goes into something, and we measure that through liters and milliliters. Now, there is a conversion chart to this that helps us. So I always like to kind of do the equal parts of boxes. So again, if this was like a bar model and I said, well, this is 1 liter, right, using that L, then the equivalent is 1,000 milliliters. So that's the equivalent. So that's what we're working on here, is that 1 liter is the same thing as 1,000 milliliters. So obviously, if you had 2,000 milliliters, that would be 2 liters. So a 2 liter of soda, which is a very common thing we buy at the store, which, gosh, doesn't look like that either. Holy, my drawing of the 2 liter, weird. Regardless, the 2 liter sodas, those larger plastic bottles you often buy, that has 1,000 milliliters worth of liquid in it. That's how we measure that. It's also 2 liters, which is how we measure that because they're equivalent. Okay, anyway, God, classic me. Let's talk about a bunch of stuff before we do math. Wait, this is math we're talking about. Cool, let's do it. So let's get into it today. We are going to continue then to explore this idea of converting. Now, if you've watched the other videos on converting units of measurement, you'll know that we have a 3-step process today. If you haven't watched the other videos and this is your very first video you've ever watched on converting units of measurement, congratulations, you win the prize. Because I'm going to tell you the 3 steps anyway. So what we like to do here is one, we like to set up a T-chart. A T-chart is a really good friend when converting units of measurement. And when we set up that T-chart, we also have a second step in which we call how we get the one to many. Like I said, if you've watched other videos, this makes sense. If you haven't, this is the first time you've used this, heard this term, don't worry, I'm going to explain it very soon. Once we've done that, we'll move on to step two. And step two is to find our rule. So this is really that concept of like an in and out box. If you've done those before, if you've worked with me before, you know that is something I enjoy doing. It's the in and out box. It's also could be one way you could look at it is it's where we make the equation. It's where we make sense of the constant rule that's occurring with our numbers. And then finally, we're just going to solve for the unknown. So solve for unknown. And I'm going to try to keep this one page up, and I'm going to try to flip back and forth to this page to remember these steps. But that is really the three-step process of solving, converting units of measurement. And you could do this with any unit of measurement, whether you're converting cups and pints and gallons. Maybe you're converting feet, yards, inches, miles. Maybe you need to convert tons and pounds. I don't know why that was so hard for me to think of all of a sudden. Things like that. It's like no matter the units you're converting, you can use this three-step process. It just so happens that we are going to be using liters to milliliters today, but we will be doing so with, again, these three same steps. So let's go ahead and get into an example problem because I've talked a lot and we haven't even done any math yet. Yay! So classic me. Okay. So let's start with a problem. Let's just say again, if you've been here before, you know I'm always about the random person that just comes up and says, "Hey, tell me about math." So again, here's the random person. They're like, "Listen, check this out. This is my voice when I'm telling you, asking you random math questions. If I had 2 and 75 hundredths liters of soda, sure, or whatever, how many milliliters would that be?" Right? That's the question. Hey, Mia, I'm asking that question. So that's what you get. 2 and 75 thousandths liters. How do we convert that to milliliters? So let's play the game. And the game's called Follow the Steps. So let's go back to our steps. Step one, we're going to make a T-chart and we're going to do the one to many. So again, let me explain what that looks like. So T-chart. That one I think we know. We're friends with the T-chart. So I'm going to go ahead and I'm going to build a little T-chart. And I'm going to talk about the two units I have. I have liters, so I'm going to write an L here for liters. I have milliliters. I'm going to write an ML right here under that as well. So that gives me my milliliters. So those are two things. Now, I want to go back to the one to many. And what I mean by the one to many is that before I even think about the problems I have in my math here, right, this problem up here, I actually want it so that I have either a number one here or a number one here, meaning, and this is what I always mean by that, meaning that the conversion is either 1 liter is equal to many milliliters or 1 milliliters is equal to many liters. And we know that if we go back, and we're going to go back to this page and look, and this is where we see the one to many, because here is my one. My one right here is I have 1 liter, and 1 liter is the same thing to many milliliters. In fact, it's equal to 1,000. So that's what I mean by the rule of one to many. And this is the rule. 1 liter equals 1,000 milliliters. So if we come back here, we can write that rule in. And again, I'm going to do that. I'm going to say 1. No, I'm not, because I'm going to forget to put the pen on. There we go. Let's do this again. I'm going to say 1 liter is equal to 1,000 milliliters. Now, this is great because this is really about base 10 work. And I kind of I think I alluded to that earlier, but the cool thing about the metric system is that we're always using base 10. So we're just going to be thinking about that. All right. Now, this is what helps me make my rule. So let's see. I'm going to put that right here. I'm going to say rule. And if I look at my rule, this is what it states. I start over here with my X. I always say the first one in a T-chart is an X. And in this case, not to be too confusing, I'm going to say L. I'm going to say, well, if I take my liters and I go from 1 to 1,000, well, then I'm getting larger, right? So that tells me I'm multiplying. So if I take my liters and I multiply it by 1,000, then I'm going to get an answer in milliliters. And that's what my rule states right here. Here's my rule. This is actually step 2 of the process, find the rule, is that I can see that anytime if I had 1 liter, I'd have 1,000 milliliters. If I had 2 liters, I'd have 2,000 milliliters. If I had 3 liters, I had 3,000 milliliters. And so the rule is just telling me to multiply by 1,000 to get milliliters. That's my rule. L liters times 1,000 will equal milliliters. So now I go do that. That's step 3. I'm going to solve for the unknown. I guess I've been saying the steps and not showing them, so I have to now. We're going to go back here. So that's what we just did. We just did this piece. We in and out box made an equation. That was the rule. Now we're going to solve for the unknown. So let's go back to our problem and just say, okay, well, what do we know? Well, the unknown right here is milliliters up right here. Sorry, let me get there. This is our unknown. This is what we're trying to solve. What we do know is we have 2 and 7/500 milliliters. So I'm actually put that in my T-chart. And what I'm saying is, I don't know how many milliliters that is, but the cool thing is, I have a really cool rule to help me. Because this states, this is substitution. This really does state for me that if I, in place of this L right here, if I substitute it with 2 and 7/500, which is what I'm going to do over here, I'm going to say 2 and 7/500, and then I'm going to multiply that by the rule, which is 1,000. That's going to get me my milliliters. It's going to give me my answer, right? It'll tell me. So let's do that. Now, the cool thing again about base 10, especially in this term with decimals, is we also have to remember that we could just use the gifts of base 10 multiplication. Oh, gosh, it's so good. Because in this case, let's think about this. If I took 2 and 7/500 and multiplied it by 1, I would still have 2 and 7/500, right? The identity property of multiplication, nothing changes. But it's not 1, it's 1,000. And what that means then is that my problem is getting 1,000 times bigger. What's also so great about that, though, is again, I'm multiplying by 1, so my digits don't change. They actually just change place values. And in this case, again, we have 1, 2, 3 extra place values. So all these digits move 3 place values. I'm going to go to another page to show this because I don't want to cram it in here. So let's go to another one and let's talk about what that means. If I have 2 and 7/500 and I'm multiplying by 1,000, that means I'm moving 3 place values. That means this digit is going to move 3 place values up. So if it was like the 2 right now is in the 1's place, well, if I move to the next place value, it'd shift over here and that would make it a 10. That's 1 jump. And then it'd come over here and the 2 would move over here to the hundreds, right? That's 1, 2 jumps, but I said it's 3 jumps because it's 3 zeros. So I'm going to move 1 time again, and that puts my 2 in the thousands, right? Thousands. It's hard to get in there. So there it is. It jumped. And then we can look at the other digits and think about what we did there. I'm going to do it in another color because this is not getting fun. So the other numbers were a 7 and a 5. So now let's think about the 7. The 7 also jumps 3 times. So there's 1, 2, 3. So now the 7 that was once in the tenths place is actually in the hundreds place. And then our 5 is also going to jump 3 times. So 1, 2, 3. So it ends up in the tens place, leaving me with an empty ones place, which means if it's an empty place value, I definitely can put a 0 in there to get my answer. And that's what we get. 2 and 7/500 liters, actually 7/5 hundredths, sorry, 2 and 7/500 of liters of soda is the same thing as 2,750 milliliters. Here's my answer right here. Sorry, these moved. They're gone. Here's my answer. It's right there. So let's go put that in. That was hopefully not too confusing. A lot of steps and a lot of talking. So 2,750 milliliters. So that would be my answer. So that's the convert. Oh, I can write it up here too. 2,750. So that's how I converted. That was a lot of work. I don't know. We're already like tick tock, tick tock. Let's do another one just so like maybe we'll take it. Let's scale it back a little bit. Let's try one that's a little less like, whoa, that was so intense. let's start with this one and let's just say, okay, we have 3,000 milliliters and we want to know how many liters we have. So again, let's go to the steps. Step one, I'm going to make that T-chart. So I'm going to do that right here. And here's my unit of measurement. I have milliliters and I have liters. And then again, I have to do that one to many. Like, is it 1 milliliter equals lots of liters or 1 liter to equals lots of milliliters? And that rule doesn't change. In fact, we just learned that. What we know is 1 liter equals 1,000 milliliters. That's the one to many rule. Next, I can think about what my rule is, right? So my rule then, if I look at this, I always like to start, like I said, I always start on the left side of a T-chart, which that's like normally the X. And if that doesn't make sense, it will when you get into middle school. Or if you're in middle school, then you're like, yeah, I get that. Or if you're in middle school and you're like, yeah, I don't get that. Don't worry. We can do a video on that too. We got you. Ain't no thing. Anyway, I'll start over here. And what I'm noticing is that if I take my milliliters, right? And this time I started at 1,000, but I ended at 1. So I actually got smaller. So I'm actually not multiplying this time, I'm dividing. If I take my milliliters and I divide it by 1,000, because that would make sense. 1,000 divided by 1,000 equals 1. Then that's what I'll get. I'll get my answer. My answer isn't always 1. My answer will always be liters. So this is my rule right here. Right? My rule states that milliliters divided by 1,000 will get me my answer for liters. So now that we've set that all up, we can actually start doing the problem. And that's the cool thing about this process with converting. Like I said, it's you can do any and any units of measurement as long as you follow these same steps. It works every time. So what we know is we have 3,000 milliliters and we're trying to figure out how many liters that is. So now let's substitute. Instead of this milliliter right here, wrong color, this one, I'm going to substitute it with 3,000. So I'm going to say 3,000. And we're still dividing. That rule's not going to change. Divided by, and we're still dividing by 1,000. That rule doesn't change either. But now we're going to get an answer because now I'm going to solve for that L. And if I have 3,000 divided by 1,000, well, again, this is base 10. Oh, I love base 10. 3 divided by 1 would get me 3. And then this is where, if you watch these, I have videos on this. So if you're not sure how to do this base 10 division, you can go watch the video on this. But this is what I call do the laundry. We're going to match the socks. So this 0 matches with this 0, so they cancel out. This 0 matches with this 0, so they cancel out. And this 0 matches with this 0, so they cancel out. So actually, there's my answer. It's 3 liters. 3 liters. That's what I got. Okay. I'm going to speed through one more. So again, a cool opportunity to just pause and try the problem on your own and then unpause and see how we did. Okay. So this is the last problem, then we'll move forward. I feel like I've really talked a lot. I love this. I'm really excited, but I also don't want you sitting here watching a video for like 18 hours. So here's the problem, and then go ahead and pause and try to solve. If we had 400 milliliters, how many liters would I have? Okay. All right. So hopefully you paused and just solved this. And if you haven't yet, you can pause me now. I can't. I love that joke all the time. You can pause me now and do it. But either way, I'm going to get going. I'm going to pretend you paused and you already did this work on a piece of paper or in your journal. And you're like, okay, let me see if this makes sense. So step 1, we're going to make a T-chart. We're going to use our units of measurement. I have milliliters and I have liters. Step 2, actually step 1A or B, it's part of the same step. This 1 is my one to many. And we've learned this now. We now know that 1 liter is the same thing as 1,000 milliliters. Okay, step 2, I'm going to make my rule, right? My equation. And my rule states, if I look at this again, like I always said, I always like to start on the left side. My rule states that if I take milliliters, and again, I got smaller. I went from 1,000 to 1. So I'm dividing. If I take my milliliters and I divide it by 1,000, I promise that says 1,000. I'm going to erase that and rewrite that because that looked really horrible. If we divide that by 1,000, then we are going to get our answer in liters. It's like I have so many colors and I keep kind of picking the same ones. Okay, so there's our rule now. milliliters divided by 1,000 equals liters. Well, let's go solve our problem. Let's solve for unknown. That's step 3. And what I know is I have 400 milliliters. So now I'm going to substitute, right? Again, this 400, I'm going to, whoa, I don't know what I just did there. Sorry. I just hit a bunch of weird buttons. Probably did nothing for you, but it made my screen go crazy. I'm going to substitute 400 for this milliliters. I guess I should have done it in the red color. I'm going to substitute. That was confusing because I made it the same color as the liters. That's so confusing. I'm going to substitute this milliliters with 400. So I'm going to now say 400 divided by 1,000. And that's going to give me my answer. And my answer will be in liters, but it will be my answer. It will equal my answer in liters. So that's what we got to do. 400 divide, or 400. It's 400 and I put a comma in it. I hope you were like screaming at the screen like, bro, get your math straight. All right, 400 divided by 1,000. Well, that is, I'm going to do that math over here. I'm going to get this arrow out of the way. That is actually rewriting this because I'm starting with a smaller number, right? That's literally like 400 divided by 1,000, which can feel really confusing. So knowing that, I know that that's going to actually end up being a fraction, right? So I could say that this is the same thing as 400 divided by 1,000. And then we can also play that really fun game of canceling zeros like we do when we divide, right? I can say this 0 and this 0 cancel, this one and this one cancels. So now I have 4/10. And then what's cool about that is, look, I have 4/10, and I could actually write that as a decimal. So I have 4/10 of a liter, or 4/10 of a liter, or if you wrote 400 thousandths of a liter, that's acceptable. These are all acceptable answers. So I hope that made sense. I hope this video wasn't too long. I feel like it was. I gotta admit, I had a good time. It was fun to be back. And you're like, again, what do you mean being back? Like, I'm just watching videos on the internet, but whatever. Let's just remember, this is the key to converting all units of measurement. T-chart, one to many. Find the rule, then solve for the unknown. That's it. I need to stop talking because, again, we got a long video, but you did great. Keep up the good work. Ask questions. We got you. Peace out.